Today's about factoring, starting with the stuff that you already know how to factor. That's going to be the top half of this page. And then introducing a little bit more factoring, some newer type stuff. And based on the new stuff that we do today, I'm then going to build off of that tomorrow into an even bigger method. So we're kind of laying a foundation today for some later work. But before we get there, let's take a look at the ones you already knew how to do. For that first one, notice that that first expression has an x squared in it. It starts with x squared. The fact that that is a 2 as our exponent is very telling for what I'm going to need to do with it, because it goes x squared, then x, then number. Whenever I see that, I'm thinking that the method I'm using is what two numbers add to the middle number and multiply to the last number. That's my method. And so what adds to 15 and multiplies to 56? 7 and 8. And so then my final answer is x plus 7 times x plus 8. Or x plus 8 times x plus 7. Remember, the order of the parentheses doesn't matter. And again, I knew to do that because it started with the x squared. Take a look at the one next to that. Here we have 5x cubed plus 15x plus 50. It's a cubed here, which means that I do not do add to multiply to. I need a different method. So how else could I factor it? Well, the other type of factoring that we have done to this point is where we can actually divide the same thing out of every term. We're doing distributive property in a reverse, remember. And so if I look at every single term here, I can divide them all by 5. And so I'm going to pull the 5 outside the parentheses and then put inside what we get there. So that's going to be an x cubed, a 3x, and then 50 divided by 5 is 10. That one's done. That's as good as it gets. All right. Next one. The x cubed plus x squared plus x. Yes, it has an x squared in it, but that's not the biggest exponent, so no, we're not going to do add to multiply to there. But I can do factoring kind of like what I did up here, because there's something I can pull out of every single term. There is an x in every term, yeah. And so I'm going to factor an x out. If I do that, I'm taking one x out of the x cubed, so that leaves me with x squared. Then 13x squared becomes 13x. And then this is the tricky part. Make sure you remember the last one, because x divided by x is 1. And it's really tempting to forget about that part if we aren't careful. So make sure you're getting that part in there. Now, some of you might be actually really astute looking at that answer and be thinking, wait, now it starts with the squared. Can we factor it now by doing the add to multiply to? Yes and no. There will be problems that you'll be seeing later on down the road. I'm going to save them for a little bit, where we will factor doing add to multiply to at this point. Why am I not going to do it here? Because what adds to 13 and multiplies to 1? Nothing. That one is not possible to do, because the only way you can multiply to 1 is 1 times 1, and obviously that doesn't add to 13. So that's why we're stopping there. All right, next one. All right. Again, I start with a 7 next to the 7th, so I'm not going to do add to multiply to. So it's like the last two we've done, so I'm looking to see what can I divide every term by. First, I'll look at the 12, the 16, and the 36. What can I divide all three of those numbers by?
6x cubed.
Looks like I could actually divide, let's see, the 16 is the tricky one. That's the one that makes it basically only a 4. So I can pull a 4 out of all the numbers. But again, we also have x's in every term. The 7th, the 4th, the 3rd. So how many x's can I pull out of every term? 3, absolutely. And so I'm actually going to factor out 4x cubed here. And so then I divide each term by 4x cubed. So that becomes 3x to the 4th, plus stays a plus, 4x, plus stays a plus, and 9. Notice it's not 9x, because I took all three of the x's out, and so there are no x's left on that 9. This one is now done. That one cannot factor anymore. You'll notice there's nothing else I can divide out of every term. And it's not a squared or anything, so yes, we know we're done. All 4 of those are ones that we've done before, to varying degrees. We haven't done tons of practice, but you can bet that you're going to be getting a lot more practice coming up, because basically this unit that we're heading into is all about quadratics, and splitting unit 4 up into 2 parts. And this first part is all about graphing, which was yesterday, and factoring, which is today and tomorrow. And then just all the different little variations that we get with them. So, now we're on to our newer method today. For this next problem, 13xy plus 9y. That one actually looks a lot like some of the previous ones, right? What can I factor out of both terms?
Y.
The y, absolutely. And so that just becomes y times 13x plus 9. Because what I'm doing is I'm looking to see what appears in every term, and I'm dividing that out. Okay, so then if I look at the next problem, what do I see in every term here? Yeah, we see that g in the x. You notice it's written in both cases as g parentheses x. You'll notice if I write it that way, that's a function. So it's basically telling me that I can actually factor out the function g of x. Now if I do that, notice what's left behind. The 13x and the 9 are both left behind. And so it's g of x times 13x plus 9. And I did g of x in there because g of x can therefore represent any mathematical function. But you might not be thinking of it that way. So to bring the idea home even more, I created this one. What do you see in every term? The smiley face. It doesn't matter what it is in every term. It can be a particular letter. It could be a whole function. It could be a smiley. It doesn't matter what is in every term. We can factor it out if it appears in every single term. And I did that in order to make us able to do this last problem, because this last problem is the type that we're going to be doing a bunch of today, and it's the main focus. What do you see in every term here? It's 4x plus 7. That could be what g of x equaled before, and it would still work the same way. It's its own little function. But since that appears in both places, I can pull that out, and notice what gets left. The 13x is still there, and the plus 9 is still there. And so the whole thing equals 4x plus 7 times the 13x plus 9. All right, so the first one, I mean, that looks pretty much kind of like what we were just doing on that last one, right? So let's see what is in every term. And notice we got 6x plus 1 in both terms. So I can pull that out, and then notice what's going to be left behind. The 32x and the minus 17 are left behind when we pull those out. So then this is what we're looking at. Okay. We repeat the process for the second one. So in the second one, what are you going to factor out of every single term?
8x minus 5.
Yep, the 8x minus 5. Good. And so then what's going to be in the other parentheses then? The 3x and the plus 10. All right. Those are doable. And the last one, I see that I have the 7x minus 11 here, but then the last part's a little bit tricky. It's a little bit weird, right? Because I don't want to like say, okay, well, what goes into 7x and into 11? Then I'm looking at every term. But of course, this is 7x minus 11. But if I do that, if I factor out the 7x minus 11, what's left behind? And if you're not sure, I'll show you here a way that you can write this that actually helps with it. Because if in doubt, remember in math, it's a nice general rule you can use. If in doubt, make it look like something you already know how to do. So if I wanted to write parentheses around this, what number would be in front of those parentheses? And so if you do that, so if you see one of these and you get stuck on it, write it like that, and then you'll know what to do with it. Now you don't have to do that, but certainly if you're not sure what else to do that. Because if I write it like that, I then can see I got 7x minus 11 showing up twice. And what's outside is the 9x and the plus 1. And so there's our actual factored form. All right, so the first one, that followed up directly with what we did before on the previous page. But this next one, the second one here, it's a little bit different, right? Because we have the 5x plus 4 there, but over here, it's a 5x minus 4. And yes, that minus makes a difference. We do have to either deal with it, or we aren't going to be able to do it. So the question is, can we deal with it? And what makes it important to see here is the fact that it's not just a minus 4, but it's also a minus 5x. And the fact that both of them have had their signs switched compared to the original means, yes, we can do this. In this case, they happen to both switch from positive to negative. But of course, if they started negative, flipping to positive, it would still work. So what can we do then? Well, I want to put the 5x minus 4, or the plus 4 here. What would I factor out in order to do that? We'll factor out negative 1. And so again, this is one of those lines that you don't have to write in, but if you're not sure what else to do, writing it in will make a big difference. It'll let you be able to do it. Because once I have it written like this, I know how to factor it, because it looks like the previous ones that I've done before, and like these. So go ahead and finish factoring out those last two if you haven't yet.